Awesome. Yeah, sure. Thanks for the introduction and thanks y'all for being here this evening. It's great to see some familiar names and folks from all different regions. This evening, I'm going to focus on talking a little bit about our kelp data in Washington, our kelp program in Washington, um, and look at our species composition across the Puget Sound or Salish Sea region. So the Washington program started officially in 2022. So we're going to have, uh, we'll see data from those first like 3 full years of surveys. There are a handful of sites, I believe, like 7 sites that have data from 2021. We had a pilot year, so you might see a few sites with some additional years of data. Um, and then in our first year, we surveyed 30 sites, and now we survey over 60 sites annually between our Washington waters and a little bit over the border in British Columbia. And so um, again, because we have site additions, there might be some varying amounts of years represented across each of those sites that we'll look at. And we will be focusing on our data in Washington and not those BC sites just yet this year. Because that's a lot of sites to look at all at once, we've broken down our sites into broader categories looking at sub-basins across the Puget Sound region. So I'll get you oriented a little bit to those. These are um, sub-basins defined by Washington Department of Natural Resources, and in general are defined by large underwater sills, so where there's glacial deposits underwater, or by geographic features. So um, looking at our map here, and you'll see this a bunch throughout the evening, we have a lot of sites within Puget Sound, so a handful um, up north, a handful on the coast. Um, we only have 1 year of data from those coastal sites, so we're not going to look at anything that's out there, but we will look at all of our sites within the rest of those basins represented. You'll notice that there is a varying number of sites within each one. Some of that is due to um, area size. They're not all the same amount of space, available kelp habitat, and then the ease of accessibility for surveying and divers. So there's a lot more, for example, in central Puget Sound, where there's the majority of our population versus some of those other regions that are further out. Um, just like all of our Reef Check programs, our data is comparable to our other regions. So we're using similar protocols that we use throughout our kelp forest monitoring program here in Washington. Great. So we'll start by looking at our uniform point contact or UPC data. Some uh, slight differences you might notice for UPC in our estuary environment that we have here is we have an additional type of information. We collect super layer, so anything laying over the top of our data points. We have a lot of understory kelp that kind of lays across. We push that out of the way. We'll count it as super layer, push it out of the way, and then have the same other 3 categories: substrate, cover, and relief. I'm going to focus on substrate, and we use or we have quite a few more categories of substrate that we use here as well. And that is to better capture, again, that estuarian environment. And so you can see our breakdown. We have sand like we do in other regions, additional pebble category, and then our cobble is broken into cobble and rock, so it spans 2. Your typical category spans those 2. We've split boulder into small and large boulder, and then reef. And then we have some additional shell hash. We have a lot of that like broken down um, shell hash layer, or like broken down shells that create substrate, and then clay. And in our case, it's not soft sediment, it's compacted, so hard pan clay, and then other. And the reason we're going to focus on super layer, or sorry, substrate, is because it is uh, an important habitat building structure. So without appropriate substrate, we won't have kelp habitat. Um, and it is thought to be or considered one of our driving factors in kelp loss in the region. So we can take a look at how our substrate is distributed. So taking a look at our proportions by basin, our figure here is showing all of our basins kind of from north to south within the region. And then the yellow is going to be that finer um, substrate. So from sand all the way to reef, and including that other category. And so taking a look at those proportions, we can see that they vary greatly amongst the different basins. Looking at these three, the San Juan Islands, the Western Strait, and Hood Canal, they have the greatest proportion, so more than 30% of that rocky reef or reef greater than 1 meter. The Saratoga would be Admiralty and South and Central Puget Sound, um, are characterized primarily of our substrates that are less than 15 centimeters, so that cobble and smaller, so a lot smaller grain of of sediment, which is in a high current environment. When there's smaller substrate, kelp is going to have a harder time staying attached to some of those habitats. And let's take a look at how this substrate data compares to our kelp data. So again, we're doing the same type of kelp swath here, 30 meter by 2 meter transects, and counting 13 species of macroalgae. So we have 3 species that are stipitate, 3 species that are canopy forming. However, our primary canopy forming kelp is bull kelp. We have 5 species of understory kelp that we count, and then our 2 species of kind of labeled as other. We have acid weed and that invasive wireweed. So if we plot all of these species that we're counting across our basins in a multivariate plot like this, let's take a look at what this is showing you, and then we can talk about what it means. So a multivariate plot is taking a bunch of different variables and putting a dot on the graph where they are. The closer the dots are together, the more similar those community composition are. The further apart, the more different the composition is. On this chart here, we're looking at all of our kelp data, and each of our basin are color coded. Each dot is a site within that basin. And then for any basins with more than 4 sites, you'll see an ellipses, or that circle drawn around kind of the central part of that grouping, what makes up that species composition. So if we look at our south and central basins, so they're the pink and the blue ellipses, you'll notice there's extreme overlap there. And so that means that those 2 basins have very similar community compositions, but by those overlapping ellipses. That's these guys right here down in the south and central. Are and again, those were the basins that had more smaller substrate categories. dominated by smaller substrate. Our basins with more reef substrate also tended to group together. So the Eastern Strait and the San Juan Islands. So that's the green and this like peachish color, reddish. Had similar compositions as well. And in general, the basins with more reef substrate had more of our canopy kelps. I will say, with the exception of Hood Canal, where there's no historical presence of bull kelp or canopy kelps, and that's that little like J hook waterway there. Right. Also of note, our species or our basins that had more of like a mixed substrate category were characterized by having more of our stipitate species, so that woody and torn kelp. In general, basins north of Admiralty Inlet, there's a big sill right here that's pointed out on the map here. Basins north of there had a higher species richness, so there were more diversity there with 11 to 12 species compared to our basins that are south of Admiralty Inlet, many with less than 10 in each. So looking a little bit more specifically at different species type, our sugar kelp, which is a mixture of our a couple different laminaria species, because they're very similar. We don't distinguish them by species, but our sugar kelp complex was found across all of our basins and consistently in high densities. Some reaching means as great as 100 individuals per 60 square meters. So we can see that in our chart or graphs here. Basins with the highest density had higher occurrences of substrate less than 5 centimeters, which is interesting. So our understory kelp might be a little bit more inclined to smaller substrate compared to our canopy forming. And then the other species that was found across all of our basins was our invasive Saccharina, our invasive sargassum, which was also present with the highest densities occurring in the Central Basin with about 3.2 plants per 60 meters squared. Great. Moving on to our stipitate kelps. Again, our stipitate had the greatest variation in density. So you'll notice on these charts, they don't have the same scale on that y-axis. So this is our densities. They're much more varied. And that's so we can actually see the differences from year to year within each basin. And so looking at some of our basins with the highest densities, we saw the highest densities of stipitate kelp present in the San Juan Island Basin and the Strait of Juan de Fuca basins, some reaching as great as 200 individuals per centimeter square. Most of that stipitate is represented by our woody kelp versus torn. The torn kelp occurred at much lower densities across all basins, even if stipitate kelps were present. Right. Zooming in on our primary canopy forming kelp, so bull kelp, it's in all of our basins except Hood Canal. So we did see it across the entire region. Hood Canal is a fjord and doesn't really present good conditions for bull kelp forming, but they do have understory species. Basins that had more mixed substrate experienced higher densities of bull kelp, including the North Basin and the Eastern Strait of Juan de Fuca. Notably, basins dominated by reef habitat had the lowest densities of bull kelp, So that's an interesting uh, thing to know. Uh, this is shown as trend data, and my my folks in California, you guys have a few more years, so you can actually look at trends over time. Um, Unfortunately, if you see any changes across year to year here, it's a little bit anecdotal, and often artificial increases due to adding sites from year to year. So the number above each point is the number of sites surveyed that year. So you can see, for example, like the South Puget Sound didn't all of a sudden get a ton of more kelp. We just added 3 sites from 2022 to 2023, and most of that increase came from one site in particular. Oh, I didn't show you all my little figures. Sorry about that. We do get giant kelp occasionally. It is only in our most western ocean, nearest to the ocean basin, the Western Strait of Juan de Fuca. Um, we have 2 sites out there, CQ Point and Clallam Bay. Hmm. Both sites had relatively low densities to other kelp species that were present there. Um, and there shows a little bit of change again from year 1 to year 2 of data collection, but there's some significant overlap with that standard error bar. So um, not any like notable trends from one year to the next. Great. We'll take a look at our fish swath next. Again, a 30 meter by 2 meter by 2 meter swath. We have 28 species or species groupings that we look at here in Washington. So we have 4 perch species. Um, 3 of our greenling species, 14 rockfish, 3 sculpin species, 3 chondrichthyes, so you can think like sharks or chimeras, and then we do count forage fish, but we don't identify the species, so they're kind of lumped. But it does include things like sand lance, surf smelt, herring, those sorts of things that other fish like to eat. So we made a similar uh, multivariate plot that we did for our kelp communities, but for our fish communities. So again, we have those dots on the map are sites within each of those basins and ellipses around the basins that have more than 4 sites. And we can see that our central and south basins, just like with our kelp, had communities had some pretty significant overlap as well. So a lot of similarity between those community structures, and were primarily characterized by higher relative abundances of perch and sculpins. Our San Juan Islands and the Straits are also, again, with some overlap, had a lot of similarities, and were grouped by communities associated with multiple rockfish species and greenlings. There was some overlap in fish communities between the Central Basin and the Eastern Strait of Juan de Fuca, and in the north in Saratoga. Um, oops, sorry about that. Saratoga and Whidbey basins. So there was a little bit of overlap in those other areas as well. Interesting, Hood Canal, while it doesn't have any canopy forming kelp, was more similar to those in the central and um, was more similar to species in the central and south basins than to those in the Straits and San Juan Island. Moving to our invertebrate swath. Again, 30 meter by 2 meter swath. We have 29 species of invertebrates that we count. We only have 1 species of abalone that occur here, so pinto abalone, 5 species of mollusks, other kinds of mollusks, so shelled animals, 3 species of urchins, 11 star species, 2 groupings of anemones, so those large anemones and our plumose anemones, 5 crab species, and 2 cucumber species. Great. So again, plotting those invertebrate communities on our multivariate plot, we can look at our Central and South Puget Sound, so that blue and pink ellipses again, and notice that there is again some pretty significant overlap in those areas. Those two basins are dominated by relatively higher abundances of crab species. So you can think like Dungeness, rock crabs, kelp crabs, our large anemones, and our Metridium, and then a few of or more diversity in our star species, so mottled stars, ochre stars, leathers, and short spined. Our sites again up north, so in the Straits and in the San Juan Islands, were again very similar with some overlaps and characterized by greater abundances of our echinoderms. So you can think like various stars, cucumbers, including all three of our urchin species, the red, purple, and green flesh pallid urchin. Similar to our kelp communities, I don't have another one. Similar to our kelp communities, our species richness in our basins north of Admiralty Inlet, so that that kind of like marker in the just above the Eastern Strait, had a higher species richness, so 19 to 25 different species present compared to those south of Admiralty Inlet, and the lowest species richness was 12 in Admiralty Basin, so that like little basin just south of the sill. But it could be that that's due to there's only one site that we survey within that smaller geographic area. For invertebrates, we're going to zoom in on some species specifically because they have some potential impact, or they are species of interest. Maybe they're on the like an endangered list or something like that. So we're going to zoom in on a few different species. The first being our kelp crabs. We are interested in kelp crabs because they are potential grazing pressure and cause of kelp loss in some potential driver of kelp loss in some regions. Because we want to capture this grazing pressure, we record them as either adults, so kelp crabs that have a carapace greater than 5 centimeters, or juvenile kelp crabs that have a carapace less than 5 centimeters. So you can see those separated here by either blue or green. And notably, our kelp crabs are present across all of our basins, and the highest density occurring in the South Sound, which incidentally is also where we tend to have the greatest occurrence of kelp loss. And then in general, it's a little bit hard to tell from this layout, but in general, the further you move from the entrance of the Strait of Juan de Fuca, so the further inland from the ocean we get, the higher density of total kelp crabs that we encounter. Okay. Another species of interest is our pinto abalone. They are listed on our endangered species. There's a lot of restoration effort toward reintroducing them to their native habitats. And so it's a species of note when we encounter them, which isn't very frequently. And so rather than having densities, you'll notice on here, it is our total count of pinto abalones that we encounter, because we just don't encounter them all that frequently. These are the only 4 basins that they occur. So we've only found them, again, north of Admiralty Inlet, nothing south. And the N number that you can see on here is the number of sites that were surveyed in which those encounters occurred. Again, with just a couple years of data, it's hard to say if there's any significant increase from year to year, since we only have 2 years of data, and because we encounter them so infrequently. we might just miss the section that they are hanging out in during that survey that year. So, um, but it is interesting to note how many, and then we also measure the size of the abalone that we encounter. And something that's interesting is that during the 2023 and 2024 surveys, the smallest recorded abalone we found was 5.5 centimeters, and the largest being 20, with the median size being 13. Again, sunflower stars are a species of note. There's a lot of reintroduction effort and lab research and rearing of sunflower stars to reintroduce and increase the natural population. And so when we encounter our sunflower stars, we again count them on or off transect and record their size. We found sunflower stars in a few more basins than we did our pinto abalone, with the highest density occurring in that Saratoga-Whidbey basin. Pretty much all from one site. In the last few years, we've just seen dozens and dozens of pretty young sunflower stars. Because we record the size, we can know a little bit about those changes from year to year. So in 2023, we encountered 27 sunflower stars that were recorded with a median size of 17 centimeters. And in 2024, we counted 34 sunflower stars that were observed with a median size of 15 centimeters. Great. So that was all of our density biological data that we collect. I'm going to just touch a little bit on some of our abiotic factors that we take a look at, because they can also influence the growth of kelp, either resilience or loss. And so we partner with the Puget Sound Restoration Fund on some environmental sensor buoys that are co-located with our biological surveys. So there are 14 sites where buoys are installed across Puget Sound. You can see them listed here. And we, as Reef Check Washington, maintain or steward 4 of those buoys. And if you're a Washington volunteer and want to do more work with our environmental sensor buoys, let me know, because we always need some help when we do maintenance on them. And sometimes it's during surveys and sometimes it's in the off season. So what those buoys look like is a big yellow buoy on the surface. Underwater, there is a surface housing that's attached just below the surface, and then there is a bottom housing, and that is about, so the surface is 1 meter below the surface, and the bottom is about 1 meter off the bottom. And the bottom one stays off the bottom with this small mid-line buoy. On each of those sensors, on each of those housings, we have temperature, or we have sensors recording temperature, conductivity, or the salinity. Again, we get big changes, this being an estuarine environment. A pH sensor, dissolved oxygen, and then at the bottom, we do have a PAR light logger, so we can see changes in light availability near the bottom. I'm going to just focus on one of these factors, temperature, for now, and just a couple of our environmental sensor buoys, the ones that are in the South Sound, so near the Northwest Narrows, Point Vashon, so kind of Central Sound, and then one in the South Sound, Squaxin Island. And the reason I'm focusing on temperature is because there's been a lot of research on temperature affecting kelp survivability. Kelp has 2 different life stages. The sporophyte stage is what we see when we're diving the canopy forming stuff. And then the gametophyte stage is in the winter time when it's kind of microscopic and a little bit harder to see. And there's been some um, papers that came out on sort of the threshold of survivability. So 16 degrees is about the temperature when our gametophytes see significant die-off, and 18 degrees is where our sporophytes start seeing significant die-off. And if we look at just these three sites, we can see that our Squaxin Island site hits or goes into those higher values where we see kelp die-off, particularly in the summer and fall time when our kelp is at its greatest growth period. And incidentally, Squaxin Island is also in the basin where we see the greatest region-wide kelp loss. So it's this environmental sensor data can be really important information in determining some of those factors. And usually it's multivariate, so many things affecting the survivability and growth, but temperature is one of those really big ones that people have their eye on. So a couple things just to kind of wrap up that we noticed across all of our basins is our species richness was greater north of that Admiralty Inlet sill. Species communities were distinct between subbasins and similarly distinct. So our south and central Puget Sound were similar for all fish, invertebrates, and kelp, as well as our San Juan Island and Strait of Juan de Fuca basins were similar across all survey types. And then lastly, there seems to be some correlation between species community and substrate proportions, where basins that had higher proportions of aggregate substrate like sand, shell, hash, and pebble had similar kelp, invertebrate, and fish compositions. Basins with higher proportions of reef and boulder substrate had similar species composition and had a greater diversity within their communities. And then some basins that fell within that intermediate position had greater occurrence of intermediate sized substrate. All of these figures, except for the environmental sensor data, are part of a larger report that we wrote for the state as part of our funding. So if you wanted to read more or dig a little bit deeper or look at things that are more site specific, feel free to scan the QR code and dig away. That'll be up again in a minute. But I want to thank all of our volunteer divers that go out and collect this data, and of course our partners. So our partners collect about our data from about a fourth of the sites that we survey in Washington, as well as our funders we get through the Environmental Protection Agency and through the state or the Climate Commitment Act. With that, I will open the floor to questions, and I'll also leave this up if you wanted to scan that QR code.